Welcome, Workforce Initiative participants, and welcome to Central New Mexico Community College and our Quantum Learning Lab. This is the location where just 9 days ago, we started the world's first quantum technician boot camp. And I want to take a few moments to show you around the classroom. We're sorry that we couldn't be with you in person, but while you are meeting up in Los Alamos, we will have students in this classroom working on the equipment I'm about to show you. In the Quantum Technician Boot Camp, we're going to be training individuals that come from all walks of life and prepare them to be technicians in advanced manufacturing workforce, specifically in quantum, but broader than that. The class is broken up into 4 different segments. The 4 segments start with teaching the students basic optics. And so I come over to this first table here. They just start with a laser beam that they shoot at a target. They'll run it through some lenses, maybe through different types of slits or mirrors in order to do some basic optical stuff on the optical table. Earlier this week, students started constructing their first optical instrument. This is optical tweezers, essentially uses a laser beam to grab small microscopic particles and move them around. And so this is under construction. The students are building the system. They'll learn control software. They'll learn how to move stages. They'll learn how to measure laser intensity and optimize this in order to do the optical tweezing. The second part of the class is in something known as high vacuum systems. And so over here we have 2 vacuum training systems. These are systems that you may see in the semiconductor industry as they're training semiconductor manufacturing technicians, or in the solar cell industry, or in space as well. We have a chamber here that there isn't much in, but is our volume that will learn how to pump things down. Students will first learn the basic operation of the system. They've learned how the system is plumbed. They've learned about different valves and different pumps and the sequences they need to do to bring this chamber down to about 1/1000th of an atmosphere. The students are going to be doing some maintenance on the system, so they're also learning about how the system is assembled. We have a baseline on how the system worked before there was an issue, and so their last step will be to re-baseline the system to make sure that they put things back together the way they need to be. And so we'll go through a variety of maintenance and troubleshooting stuff over the next few weeks with them in the high vacuum systems. We're going to go over to the third area of the classroom now. We'll go past these 2 optical tweezer setups that other students are working on, and we'll come to this table where we have a quantum optics setup. So this system allows the students to build a system and do experiments in the quantum world. It requires a delicate setup, so the students will learn precision alignment. They'll learn how to use various types of sensors and other optical components that maybe they haven't used earlier in the class. The last part of the class is building an actual quantum system. And so we have our main setup right here. This system uses some industrial lasers, has a variety of optics to direct the beam and condition the beams to be very specific colors of light in order to allow the quantum phenomena to happen. Ultimately, that light will find its way over to this platform. On this platform, we have a chamber that we will use our vacuum knowledge to pump down to 1/1000th of an atmosphere. At some point in about 3 weeks, the coldest point in Albuquerque will be in the middle of this chamber, where we have achieved close to absolute zero on these rubidium atoms. And then from that point on, we're able to do actual quantum operations similar to what you will have seen in a quantum computer. And so our last stop on this tour is our quantum sensing setup, thanks to some assistance we've gotten from Sandia National Labs. This system uses a diamond that has been manipulated to have some of the carbon replaced with nitrogen. It gets illuminated with a green laser, and it refluoresces back red light. And the amount of red light that comes back is dependent on the magnetic field that it's in. And so this system, which the students will learn how to program and do some data analysis on. An instrument like this can be used for oil and gas exploration. It can be used for archaeology. A smaller version of this can be used for mapping where you are in the Earth's magnetic field, and thus be able to do navigation without having to rely on GPS satellites. Our quantum sensing, our quantum computing stuff, and then some guest speakers that'll come in and talk about quantum communication will expose the students and prepare them for careers as quantum technicians. Thank you very much for joining me on the tour today.